Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Guillermo Amaral joins me. We're going to be talking about Pilosa, a way to index huge data sets and find things out about them. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Guillermo Amaral. Episode 437, recorded June 6, 2017. Pilosa. This episode of FLOSS Weekly is brought to you by GoCD, an on-premise open-source continuous delivery server by ThoughtWorks. GoCD gives you complete control of and visibility into your deployments across multiple teams. Since GoCD is open source, you can download it and use it for free. To discover the power of their pipelines, visit gocd.io/twit. And by Cloudflare. More than 6 million websites, apps, APIs, and software as a service companies use Cloudflare's services to weather whatever the internet throws at them. For a free online chat session with a Cloudflare support engineer, visit cloudflare.com/twit. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, the little projects, projects you may be using every day and not aware of it, projects you might want to download and play with right after this show. I think today will be one of those. Joining me today, once again, my lovely and talented co-host, Guillermo Amaral. Welcome back.
Hey, Randall. How's it going?
I startle
you me out with that lovely thing. I want to, just let my hair loose and everything.
Well, I started doing that for a while, and then Aaron picked it up and started doing it for a while too. So I wanted to bring it back just once, just to try it again.
It's okay. It's okay.
Yeah, and so I'm coming to you today again, as I was last week, from the ZipRecruiter's home office headquarters here on the 11th floor of one of the tallest buildings in Santa Monica. So you can see tall buildings behind me if you're watching the video, because you can see a little bit of that. And Guillermo, I think you're coming to us from your above-ground, underground bunker in beautiful Playa de Tijuana, right?
That's right. I guess the cat ranch, if you want to call it that. Right now I have 4 cats here, so it's going to be interesting.
Nice. Well, thanks for taking on this show in such short notice. I've got to say, this show has been an interesting, I'll just say an interesting production issues behind the scenes in this one, but we made it, and we're here. We're doing our show today. So today's show is about Pilosa. Pilosa was at OSCON and actually had a major release just before OSCON, and so there was a lot of commotion there about Pilosa, a lot of a couple talks being given, and a lot of PR people sending out things to me saying, well, if you're going to be at OSCON, you got to talk to Pilosa. And I go, well, I don't really talk to anybody at the show. I get them back on my show, and that way we get everything to work. So Pilosa, the simplest way I have of describing it is, well, first we can look at what they say on their website, which is in the wrong place on my screen. There it is. Pilosa is an open source distributed bitmap index that dramatically accelerates queries across multiple massive data sets. Now, let me sort of blend that down into what they were able to describe it to me before. They actually gave me the elevator pitch at the booth. So let's imagine you have a huge amount of data. And that's not hard to imagine anymore. We get lots of data going on these days. And you want to do set math on it. In other words, you assign a bunch of Boolean attributes to each one of these items, and you want to say, I want all the items that have this property and this property, or maybe this property. And you can do that with traditional databases, but the problem is, as you get bigger and bigger, they're not biased towards doing really rapid bitmap management. And so that's what Pilosa's breaking ground in, is to try to be able to do huge, massive data sets and do complex set calculations on how many people over 45 have a Maserati and live within 5 miles of downtown, that sort of thing. To be able to do that sort of data reduction, data calculations in ways that most traditional databases, even things like Elasticsearch, tend to roll over. Plus, it's also shards. It scales horizontally, so you can apply lots and lots of different equipment to the same problem. And it looks like it's going to be a pretty interesting player in this space. Guillermo, do you want to add anything to that?
I think you pretty much covered everything I also read.
Well, I ask you that question. I ask you that because I need time to bring up the ad. So
of course. No, don't worry about it. So
that's okay. Say something.
I think that something that I did find interesting in Pilosa is that I think they're right now using it for like I think for a taxi company or something. So it kind of does make sense if you do have like a really large database. I used to work in the airline industry for a while. So whenever you have something or I guess a big data set and you're just trying to figure out which clients arrive at what times, what cities are the most popular in which seasons, those queries really take a long time. It's kind of hard to program. Somebody actually needs to get down and dirty with the SQL, and it doesn't usually always work well. So I'm guessing they fixed that problem, and I'm just going to let them answer that later on, I suppose.
Yes, and we will be bringing on our guests in just a moment. Our guests today will be Matt Jaffe and Travis Turner representing the organization. But before we do that, I have a very important announcement. Because this episode of Floss Weekly is brought to you by GoCD. GoCD is the on-premise open-source continuous delivery server created by ThoughtWorks. With GoCD's comprehensive pipeline modeling, you can model complex workflows across multiple teams with ease. GoCD can easily configure dependencies for fast feedback and on-demand deployment with its parallel and sequential execution. It offers complete customization for your software's individual needs. GoCD's real power is in the visibility it provides over your end-to-end workflow, so you can get complete control of and visibility into all your deployments across the organization. It supports auditable deployment and can delegate the configuration of pipelines to users without full-blown admin privileges. GoCD will perform tests in most languages or frameworks. Their test reporting will tell you in exactly which change set and on which platform a test started breaking. You can compare content across any two arbitrary builds, making it invaluable when troubleshooting a broken pipeline. GoCD has extension points for which plugins can be created. Numerous plugins are available, or you can write your own. Say hello to consistent, predictable deliveries. GoCD is open source that you can download and use for free. Discover the power of their pipelines at gocd.io/twit. That's gocd.io/twit. Commercial support and enterprise add-ons, including disaster recovery, are also available, and we thank GoCD for their sponsorship of this show. And now, let's go ahead and bring our guests. Let's start with Matt Jaffe. Matt, welcome to the show.
Hi, thanks for having me.
And where are you speaking to us from?
We are in sunny Austin, Texas, in the historic Seaholm Power Plant.
Cool. And let's also bring on Travis Turner. Travis, welcome to the show.
Hi, Randall. Thanks for having us.
Very cool. And you guys are sort of near each other in the same building, but at least different rooms. That's always particularly handy that we take care of that. So, and I was just in Austin, like I said, a couple weeks ago. And the best thing about being in Austin a couple weeks ago is that it wasn't 105 degrees yet. Because last time OSCON was there, it was very, very hot. So I appreciate that it actually was a bit cooler this time. So whoever wants to take this, give us the 30,000-foot view. What is it, and how close did I get it?
Yeah, I'll take it. I think you actually did a really good job describing that. So, at a high level, Pilosa is, as you said, sort of a distributed bitmap index. I can maybe talk a little bit about why we built it and where it came from.
Yeah, please.
So prior to Pilosa, where Matt and I, work full time on the project now, we were both employed at a company called Umble, which is a data management platform for sports and entertainment companies. So think like professional sports teams and big media companies. And these are companies that have tens, maybe millions of fans in their databases and are collecting millions of data points about those fans. And a lot of the queries that they're wanting to do on that data oftentimes revolves around segmentation of the data. So a lot of like the examples that you gave, I want to narrow down to the females from California that like soccer, and then, perform some action on them or take that segment further and say, what are the top 10 movies within that segment that those people like, things like that. So segmentation across high cardinality data sets was something that was really at the core of our platform. And so that is really where we came from. At Umble, we started about 5 years ago, and we built our early version of the platform around Elasticsearch, because it was really the only thing out there that could kind of handle the types of queries that we needed to do. But as we grew, as we started onboarding more and more clients and seeing larger and larger data sets, Elasticsearch just introduced problems that we needed to get around. First of all, it got to be really expensive. We had a 20-node Elasticsearch cluster with like several terabytes of memory just to hold the amount of data for these sort of ad hoc queries. The ops team didn't like us very much. If a node would go down in Elasticsearch, sometimes it was a little hard to administer. And also, it just was a little unpredictable for the types of queries that we needed. We were really producing supporting ad hoc queries basically in real time. And the things that we would notice with Elasticsearch, especially on things like top-end queries, is that one time you might run the query and it comes back in a few seconds, but you might run that same query later and it takes 30 seconds because for some reason, had to pull from disk and, the data it needed wasn't in memory. So it's just that unpredictability caused us to need to look for another solution. And so what we really did in this sort of introducing Pilosa is set out to implement a service that could answer the types of queries that were really causing us the most problems with Elasticsearch. And that was, again, these sort of really high cardinality segmentation, bitwise operation queries on massive data sets. So that's a bit of background about Pilosa and where we came from.
Cool. And so this isn't to completely replace the data stores that you would use with the data because, is this just for doing aggregation, or are you also looking at maybe give me all the records that meet this criterion? Does it do the individual rows as well?
So yeah, it does store. You can get back a good portion of the data that you need. A lot of times, you might narrow down your segment and then go back to your persistent data store for a little richer data set about, that maybe in the use case of sports teams, about their individual fans. But at a high level, you can actually store a lot of relevant data and aggregate data in the index itself and not actually have to go hit the primary data store.
And what's your responsibility at Pilosa? What do you do?
So I'm the head of engineering at Pilosa. So I just, as chief architect, sort of make sure that we're on the roadmap and we're building features that are going to be useful for other people.
Cool. And Matt, what's your responsibility?
So I'm a lead engineer, and at a company this small, that basically means tackling whatever comes up, and be that doing podcasts or implementing a new compression in our bitmap storage format.
And what has been some of the biggest challenges here? And is this competing with anything else in this space already, other than say Elasticsearch?
I think one of the biggest challenges has been trying to figure out what we are competing with, and how do we explain what we are to people. Elasticsearch is a pretty easy comparison because they are an index, and you're not supposed to use Elasticsearch as your system of record, right? It's not tuned necessarily for extreme durability. And so that idea that we've kind of been pushing of the first class index and separating the index from data storage is probably going to be one of our biggest hurdles, I think.
Okay, and what's the status of the project? Is this already something that I can use?
Oh, absolutely. We have what we hope is pretty thorough documentation, and if it's not, we hope we'll get a pull request. But you can download it, run it on a single machine. You can actually just download the binary. It's written in Go, and it's very portable. But you can run it on a single machine, on a cluster. It's open source. It's been running in production at Humble for a few years now. So it's fairly stable for that use case at the very least.
And so why Go?
Why Go? That is an awesome question. I sort of fell in love with Go over the past couple years. It is a fairly simple language in terms of the features, the number of features it has, but all the features are sort of orthogonal in that they give you a full set of functionality that you need. It has great support for concurrency. It compiles really fast, almost to the point where it feels like a scripting language, and it performs really fast. And so it really allows us to use all of the hardware available, whether that's a single core, multi-cores, multi-machines. Go kind of makes it easy. It's a very pragmatic language, and it makes it easy to build large, stable software.
So where exactly are you storing the index you're working with? After you generate this, is that going to get stored on the disk? Is it going to be on your servers? Where's it going to be?
Yeah, so it's in memory mapped files, actually. Most of our operations come out of memory for speed, and then they're mapped to disk, generally an SSD, for durability. So if a node goes down, we can bring it back up without too much trouble. There's also node-to-node replication, which is configurable, so that if you truly lose a whole node, you can not have to rebuild your whole index.
So so it's memory mapped. You mentioned you can't have this on multiple servers, so you are sharing memory somehow.
So if it's on multiple servers, we use a consistent hash to decide sort of where each bitmap is, or where each slice of a bitmap is. So the client can actually query the server that the data is on, or some queries will have to go to every server, and Pilosa sort of handles sharding out the query and joining the data back together and returning it to the client.
Okay, so in this case, you would have one instance, and it can talk to multiple backends then?
So Pilosa itself doesn't talk to the backends. That's something we're discussing, but the indexing and the retrieval sort of happen at the application layer. So you might have data streaming in, and you're writing it to your durable store, and you're writing anything you want to index to Pilosa at the same time. And then on the query side, you're sort of doing the query in Pilosa to, and I think Randall mentioned this initially, to really drill down to the specific data that you're looking for out of your whole massive data set. And then once you find the segment you're looking for, if you need sort of more information about it, you would go to your durable store to retrieve that information.
Okay, so you're basically just funneling in everything that let's say if I create an application and I start querying in, let's say, who takes a trip from San Diego to LA or something, I can funnel that into Pilosa, and then when I need to query that back, I can just use your API to get that information back. That's also going to include the data for it, or is it just going to point me to the rows that I need to look up later on?
There is limited support for associating key values with each sort of row or column in the bitmap. You can think of it as like a big binary matrix, basically, with rows and columns. A lot of the time, though, what you're going to get back is a set of numbers that are either keys in a NoSQL key value store, or they might directly be IDs in your SQL database, sort of however you've decided to set things up. But you'll get back those numbers after sort of Pilosa does the hard work of figuring out exactly which ones you want out of the hundreds of millions or billions of possibilities. And then you retrieve them from your SQL store or your S3 bucket or your flat file, whatever it is, however you're storing the data durably.
Well, this might be more of a Travis question, but either one of you can answer this, whoever makes sense. Once you mention distributed, we have to start talking about CAP. Can you briefly explain what CAP is and how you're addressing it in your application?
Yeah, we are definitely focused more on availability than consistency. Because of the use cases that we've had in particular, it wasn't absolutely important that we be consistent when we're searching billions and billions of things. If we were off by 1 or 2 bits, it didn't matter.
Interesting.
But availability was very important. If Pilosa wasn't available, then the entire site was down. So Pilosa definitely, I would consider it eventually consistent. Again, that's, we don't typically have problems with that, but in our use case, yeah.
So you've got a live stream of data coming. Oh, so go ahead. Sorry.
Sorry, I was just going to add to that. We definitely want to kind of run this thing through the the Jepson, the call me maybe code, and really get some firm results on that. And eventually down the line, I think we'd love to have it be an option that you choose. Like, do you want to skew toward availability or consistency? I think Apache Cassandra sort of provides that ability for the user to choose between the two, and I think that would be great in the future.
Right, but already this probably writes redundant copies of the information, right?
It does.
Okay, and I can select the number of replicas?
You can.
Cool, all right. So what typical, what's been probably look at it this way, what's been the most surprising outcome of having written this software, or actually having, I guess for the last 2 years having written this software, in terms of being able to do a much bigger query than probably you imagined?
I have a recent one. We recently loaded in the billion taxi ride data set, which I think Guillermo mentioned. New York City released this data set of taxi rides a couple years ago. And I loaded that in, and we were sort of comparing the performance of various queries against numbers that had been published in other blog posts. And we were doing some complex query that was like, give me in sorted order, like the number of rides that have each possible passenger count at each cost, sorted by year or something like that. And it was a fraction of a second and on par with like a cluster of 8 NVIDIA Titan X GPUs, wow, which absolutely blew me away. I could not believe that.
Now, for something like that, you have to reduce everything to a bitmap. So you must take like a location start field and a location end field, and then splay it out so that it becomes just a series of Booleans, of which only one of them is set?
So the way we did it for the New York City taxi data set is each ride has a start and an end location, latitude and longitude. And we basically broke New York up into a grid of, I think we did about 10,000 squares, but you could certainly do many more. At Humble, Pilosa supports tens of millions of attributes. So each square, each location in New York is a bitmap, and if a ride started at that square, we would set a bit in that bitmap for that ride, and if it ended, we would set a bit in the end bitmap for that square for that ride.
Is there anything in the primitive calculations that would compute distances then as sort of a derived figure? I mean, you talked about shortest and longest rides. Was that just a massive way of, you had to keep going to all the different bits from start to end, or it just boggles me how you did that. So I'm looking. So how did you do it?
We actually indexed distance separately in buckets. So we would say, like these are the 1 mile rides, these are the 2 mile rides, and you can go more granularly if you need to. And this is where you get into like, the bitmap index can help you narrow down to what you want. But if you want like the actual number to extremely high precision, then you have to go back to the durable data store. Although I will say we have been working on some better support for, integers and floating point numbers. And I think Travis could tell you more about that if that's interesting.
Sure.
Yeah. So a lot of what we've been talking about so far is really equality encoding bitmaps. So, does object A have attribute, B, yes or no, it's a Boolean. There's right. A lot of research that's gone on over the last 15, 20 years in bitmap indexing. And you can get into things like range encoding and bit slice indexing, which will allow you to support sort of multi-bit values. And And with those, you can do range queries, so greater than, less than, equal to, that type of stuff. You can also do aggregates, so sums and averages. And, I mean, once you can do that, it's pretty powerful. And the exciting part about it is you can store these, effectively store these integer values, and so you're no longer just bound to Boolean values. And you can do that same thing as we were doing before. You can find a massive data set and perform a really high cardinality segmentation on it, and then perform aggregate queries on the actual values of the data itself. And you're doing that at really, really fast speeds. And that's been pretty exciting. That's stuff that we're actively working on now.
Cool. And that then begs the next question. What am I interacting with this as? It's probably not SQL, is it?
No, it's actually, we call it PQL. It's Pilosa query language. This is also something that we're iterating on. PQL right now is pretty straightforward. You can set a bit, you can clear a bit, you can intersect multiple bitmaps, union multiple bitmaps, take the difference between two bitmaps. And then we also support what we call top-end queries, which is within sort of a given category of bitmaps. What are the ones with the highest count, the most number of bits set? And so in the sort of advertising use case, that would be something like, give me the top ages or the top Facebook pages that people like in my audience. Mm-hmm. And you can sort of combine these top-end queries with intersect queries to get the top pages people like in a given segment. So of females, what are the top Facebook pages versus of males, what are the top Facebook pages?
And what are some of the applications? We already mentioned sports and things like that, and doing Facebook likes, but I think there's other big areas this might apply to. Can you talk about some of the potential uses?
Yeah, so Travis can tell you probably a little bit more than I can about a genomics use case and some biological data. I can tell you about the billion taxi ride use case, and we've also dug into network security use case. So I don't know if any one of those sounds more interesting than another.
Oh, network security is always one of my favorites.
Okay, yeah. So
let's do that.
Actually, at a previous job, I had done some work in network security, so I had a little bit of background in sort of inspecting network traffic and the problems that come up there. And we tried to sort of model the problem in Pilosa because, in a production network, a lot of the time the data rate is just fantastically large. And even doing basic things like saying, show me the packets that came from this IP address or between these two IP addresses can be quite difficult. In some cases, even just storing the full network data is not feasible. And so I wrote a little tool, which is actually open source, that will inspect your network data, pull out features like what TCP flags are set, what IP addresses, what protocols are in use, what host name if it's an HTTP request. And it will index those all in Pilosa so that you can do queries like, what are the top packets that are coming, from over UDP from port 53, to get the top DNS hosts. And so maybe you would use that to detect like a DNS amplification attack or something.
Yeah, it does sound pretty cool, definitely. And we have a bunch more stuff we need to ask, especially I know Guillermo's got a couple questions he's taken from the chat room, but I have an important message just before we do that, because this episode of Floss Weekly is brought to you by Cloudflare. Cloudflare is on a mission to help build a better internet. Cloudflare makes your site or app go faster, more reliable, and safer, so you can stop worrying about slow loading page times, downtime, or getting hacked. Cloudflare is incredibly easy to use, and sign up takes less than 5 minutes. Cloudflare's global network of 115 data centers caches your content content and moves it closer to visitors. Their web optimization features speed up your code and make it mobile responsive. End-to-end, Cloudflare speeds up every request to your site with performant DNS, caching, content optimization, load balancing, and more. Cloudflare doesn't only provide DDoS protection, their web application firewall is powered by a massive IP reputation that updates for all users. Cloudflare's 24/7 security team is constantly watching for new vulnerabilities and deploying real-time protection. No matter what you choose for your cloud compute, AWS, Azure, Google Cloud, a combination of public and hybrid, Cloudflare will work with all of them. Using Cloudflare gives your business the option to use more than one cloud provider so you don't get locked into any one of them. If you're even hit with a DDoS attack or if your site suddenly experiences a surge in legitimate traffic, you still pay the same amount because plans range from free, $20 a month, $200 a month, and custom plans for enterprise. Cloudflare is offering Twit listeners a free online chat session with one of their top support engineers to answer any of your questions. Visit cloudflare.com/twit to sign up today. That's cloudflare.com/twit. And we thank Cloudflare for their support of Floss Weekly. And now, Guillermo, you had a couple questions from the chat room?
That's right. Virgil asks, Randall, could it be used for such things as what's done in folding at home? You wanna answer that, Randall?
No, I'm not going to answer that. They are.
I'm kidding. You go, guys.
Yeah.
What was the question?
Okay. Okay, so it's could you use this for something like folding at home, basically?
I don't think so, but I'm not the guess.
So I'll take a stab at this. Folding at home is like it's part of the search for extraterrestrial intelligence, if I'm not mistaken. And you sort of run computations on radio data from radio telescopes to determine if there's any.
Actually, it's for folding.
Proteins. I'm sorry. Proteins, yes. Yeah, it's protein folding. It definitely has potential applications in biology and like trying to find similarities between chemicals for drug discovery is something we've looked at. I personally don't know much about protein folding, and I think what we're thinking about is more like the data center use case where you would have a big cluster and be making queries to Pilosa. And we haven't thought too much about distributing Pilosa among hundreds or thousands of, commodity machines of different hardware, sort of coming and going all over the world. That's not something that we've sort of been targeting right now.
Okay, well, yeah, I don't want to put words in Virgil's mouth, I suppose, but I'm guessing he probably means if you want to query that data, if all these machines already worked on folding all these proteins, and the scientists back home in wherever they live, I suppose, want to query the data set and maybe figure out, okay, so we know X number of machines that have, such processors are folding better these proteins here. Could that actual query part? I guess that could probably be something Pilosa could cover.
So do you mean like figuring out which machines to sort of throw more work at, or am I understanding that?
Exactly. But maybe they can just figure out. We know that certain machines here, or maybe better yet, not putting machines in there. We know certain time zones or certain countries where put more work into this, so we can maybe shift all the harder proteins over to them, or maybe they just want to get some stats, which proteins take longer to fold than others, stuff like that. I'm guessing this would probably fit very well in that.
Yeah, it could. I would definitely have to think about it more. But if you have millions or hundreds of millions or billions of people that are sort of contributing resources, and you want to keep stats on who's contributing what and how it's performing and what's reliable and what's not, I think that could definitely fit into the Pilosa data model.
Yeah, Pilosa is kind of hard to comprehend, I guess. Would this be something that somebody who, let's say, if I want to start using this, do I need to know how Pilosa works in the back, and behind the wall, behind the curtain, or can I just start using this and just throw data at it and try and query something back?
I think it always helps to have some idea of how things work behind the scenes. Although definitely something like Elasticsearch or Cassandra is probably easier to use at this point than Pilosa. But Pilosa's, the data model honestly is fairly simple once you understand that it's a binary matrix, and operations on bitmaps are really fast. Anytime you're combining more than one bitmap, that's going to be fast. But it definitely is in a stage where we're looking for developers and engineers, to pick this up, start playing with it, and build a community of people who want to sort of be the pioneer users of this, and the pioneers of using an independent index and splitting out the index from the database.
So is there a minimal data set that you might want to, think about starting using Pilosa, or can I just start with my project with only 10 records in there?
You certainly could do that, start with just a few records. I think Pilosa really comes into its own when you get into the hundreds of gigabytes. The billion taxi ride use case can fit on one machine, but it starts to need to be distributed at that point, and that's where Pilosa starts to really help, I think. There are bitmap libraries out there, that you can use on a single machine, and if you can fit it on one machine, it's always going to be faster than going distributed, right? Well, in general.
So would this work as a index replacement, I suppose? Let's say if you get to the terabyte size database, would I stop querying my database at some point for maybe trying to find a single user in the database? Could I just use Pilosa for that, or do I still want to use my own query backend for that?
So it's definitely going to depend on use case, but I think what we envision happening is you'll start shunting difficult queries onto Pilosa, and Pilosa will sort of drill down and do the hard work of figuring out which individual data items you're interested in. But then if you want to get something that isn't indexed, like say email address, right? Like you probably don't have that necessarily indexed, but once you figured out like what people you want to look at, you might want to find their email address. And so for that query, you would go to the durable data store, or your NoSQL key value store, and look up the 10 or 100 people that you've sort of drilled down into. And I'm lapsing back into speaking about the sort of audience segmentation use case, but that applies to many other use cases, I think.
Well, I think we've gotten geeky enough for the most of this show. I do want to start talking about Pilosa as a project as well. So, how is this working? Is Pilosa? Can I just download it and use it? And what license is it under?
Yeah, absolutely. You can download it now. We open sourced about a month ago. Like Matt said, we used it in production at Humble for about 2 years, but realized that there may be some other use cases outside of that very sort of narrow use case that we had at Humble, and it made the most sense to open source this. We opened it with the Apache 2 license. You can download it now, try it out.
And I understand that there are some patents involved. Can you talk about what those are about? And can I still use this as open source, even though there are some patent encumbrances?
Oh, yeah, absolutely. No, we had 8 patents that we included with the open source. So those are effectively, we gave those to the community. Didn't want anything sort of holding anyone back from, innovating on what we'd started. So the patents are around a lot of the distribution of bitmap queries and things like that. But again, those are all included with the open source, so no restrictions on that.
And I guess that means that effectively the patents are gone now, because, if I can build any piece of software, I can see it's derived from Pilosa, and then therefore get the rights to the patents. Yes.
Yeah, that's right. Once you give the patents out to the open source community, it's really hard to enforce them or try to enforce them, and that's really not our intention. We don't really want to sort of own this. We want to see what the community can build from it.
What was the development team like at Humble who have built this software originally, and are you starting to grow a community around outside contributions?
Yeah, we had Humble, our engineering team was about 25 people, and when we decided to open source Pilosa, we took about 9 of those and put them on the dedicated onto the Pilosa project, and it's its own company now. And we've had, like I said, we've only been open source for about a month, but we've already had good contributions from the community. So we're pretty excited about that. And hopefully, a lot of other people start to find uses for it and can help contribute.
Well, I know being on this show is probably going to give it a little bit of bump there as well. But of course, having one of the main one of the main talks. I can't talk today. One of the main talks at OSCON was also probably pretty prevalent in terms of getting you out there and getting you with a booth there too. So is the core product useful? And at what point? Because I think you have some plans of having like a enterprise level solution as well. At what point would I need to shift to that enterprise solution?
Yeah, I think, our plan right now is to focus on the open source project and building community. So, for the next year or so, that's really our focus. Because honestly, in open source, if you don't have community, you don't really have anything. So that's really where we're focusing. As far as enterprise, I think we could go the route of the typical sort of enterprise offering where, you're supporting security features and things like that are things that we're not necessarily focused on right now in the open source. Longer term sort of vision is this idea of sort of Pilosa in the cloud. So basically Pilosa as a service, register to use Pilosa, point your data store at it, configure it in such a way, and then you have an API to a managed cluster out in the cloud with which you can send queries.
I noticed I didn't see any, I might have just skipped over it, but I didn't see any authentication in the connection to Pilosa, or I didn't, is there authentication and is there auditing?
Currently, there's not. No, currently, the intention is that this would be behind your firewall and there's no necessarily authentication needed for it. That's definitely something that we would probably need to have in an enterprise version, because that's pretty much expected, I think.
Right, especially if you got PII in there, you want to make sure that you don't leak that somehow to people that you haven't authorized to do that. I'm particularly sensitive to that since I'm here at ZipRecruiter now, and there is tons of data in these ZipRecruiter databases, and so it's like, oh my goodness, if this ever got all the way out. So we've been, of course, paying attention very carefully to all the security things. We have a full security team now, which has been really cool, talking about splitting things up and making things better. But I shouldn't be talking about that because that's security. I shouldn't be telling about my security here. So we're almost out of time. I want to talk a little bit about the bioinformatics applications. Can you talk a little bit about that?
Yeah, we've been looking at some use cases in bioinformatics and sort of drug discovery type use cases. One of the interesting things that I think we've done is we've added what we call plugin support to Pilosa. So right now, what we support is Go plugins, but you could write your own custom plugin to Pilosa and effectively send your query down to the data layer. And where that comes in useful is on these use cases where completely different from segmentation, where you're asking a very specific question. More so, you're like needing to scan the entire data set and perform, massive amounts of computations over that data set. That's something that the plugin infrastructure really is good for. And so that's kind of the direction we've been moving with in the bioinformatics and drug discovery use cases.
Do you think there's going to be anything in the future that's even more scalable than this? It's a silly question, but maybe you can take it.
I don't. I mean, I would never say that. I would never say never. But when you're dealing with ones and zeros, you're at a very base level, so it's hard to get faster than that.
Yeah, and one of the articles I was reading in preparation for this, somebody said this is probably the fastest database for this stuff on Earth, and I'm wondering if they think there's alien technology that's out there.
Well,
that's right. Yeah.
There's we could do stuff on GPUs as well. So right now I think it's pretty close to as fast as you can get on CPUs. But if you have FPGAs or GPUs, I think there is a little bit more performance to be squeezed out, and we'll probably look at that in the future.
Okay, cool. And I think one of the things you might compare this to is Neo4j. Can you tell how it's different from that?
Do you want to take that, Travis?
Yeah, I wouldn't necessarily compare it directly to Neo4j. That Neo4j is a graph database. You could think of Pilosa as a graph database, like very technically, it might be considered a bigraph database. With that said, we do, if you think of the intersection where the bit set as an edge, effectively in a graph database, we're dealing a lot with relationships. But, unlike Neo4j, we're not necessarily like traversing graphs, multiple edges. We're more doing bitwise operations across those edges.
Could I build a plugin that understands graph theory and use the low-level querying aspects of Pilosa?
Oh, you're speaking my language now.
How so?
That kind of thing is something that I personally am really excited about because, as Travis said, at a basic level, you can think of data in Pilosa as a graph, and any set bit is an edge, and any row or column is a node. And because we can do computations really fast, across this graph, this very, very efficient representation of a graph, I think it has lots of applications for graph problems, which are some of the hardest and most prevalent problems around, be it social data or networks or anything else. And the plugin thing that you said is spot on, right? Like if you can sort of define computations that are going to be executed efficiently across the cluster, then you can probably do some really cool things.
Yeah, I did finally solve the traveling salesman problem in finite time. No, whatever. That's the kind of graph I think of when I think of a graph, the old NP complete problems like traveling salesman and things like that, and bin packing and all those other cool, wonderful things. Anyway, like I said, we're almost out of time. Oh, one thing I do want to say is thank you. You guys have a Docker image. I was able to get this running in 30 seconds. And I think more open source projects need to now, embrace containers, get themselves a Docker container right from the get-go, because now that I can run that directly on my Mac native and not have to use boot for Docker, or boot to Docker, whatever it was called, it's so much nicer. And everybody's moving to containers now. So I'm really happy that you had that, because I had it up and running right away, and I saw your ugly console screen, and yeah, it was actually pretty good.
Nice.
Yeah, you guys could use a graphics designer or two, but that's okay. I'm sure that's one of your call to actions will be, can we please, we want some graphic design. Okay, so we're almost out of time. Is there anything we didn't ask that you want to make sure our audience is aware of before we let you go? It's a tough question, I know.
Yeah, I think we can just reiterate that it's open source, and we're more than happy to answer questions, help people implement something with Pilosa, help people try it out. we think there's a lot of potential in this technology, distributed bitmaps, and we'd love to see it take off.
And what's the biggest missing feature right now? Tough questions.
Yeah, no, that's good. I would say integrating more easily with your existing data store, whether that's intercepting queries and splitting them out to Pilosa and the data store, or whether it's Pilosa, passing the query through. That's, I think, something people would like, and sort of helping figure out how to map data into Pilosa's data model is stuff that we'll definitely be working on.
Yeah, I think a lot of our focus is going to be on making sure it's simple, just like having the Docker container available. Like anything that makes it easier for somebody to use and understand is going to be a lot of our focus.
Cool. And 2 final questions, or else my audience yells at me. So this is for each of you, your favorite text editor and your favorite scripting language. Travis?
Text editor is Vim. Scripting language. Yeah, sorry. Well, I guess do you consider Go a scripting language? I love Go. I've worked in Python for the last several years, so I would say Python if we're technically a scripting language.
Yeah, I still don't remember. Can Go be used with a shebang line?
No. Yeah.
I don't know. Well, anyway, whatever.
So. No, it can't.
Okay, probably not. Probably needs that compile stage. So let's go ahead with Matt. Same questions.
Yeah, so I'm an Emacs man.
Yay! One from my side. Okay. Okay.
It's
but the next one, I'm not going to be happy with the next answer. I can already tell.
Yeah, I mean it's pretty much the same as Travis's. I love Go. It compiles fast enough you can almost use it as a scripting language. And before that, I was using a lot of Python. I'm also kind of partial to like Lisps and schemes and sort of slightly more functional out there languages, but I don't have enough experience in them to say what they're like my favorite.
So you use GNU Emacs then?
Sorry?
Do you use GNU Emacs then?
I do. I use Spacemacs, which is just a configuration layer basically on top of GNU Emacs.
Cool. I wrote the pretty printer for that, and Richard Stallman called it brilliant, so he put it in. So
right.
if you take an S expression, you want to put it in a multi-lines, I wrote that.
Uh-huh. Wow.
A little bit of Emacs. A little bit of me is in every copy of Emacs. Yes, it's a lot of fun. Anyway, this show's not about me. It's just about you guys. You did great describing the project, and I'm sure you're inspired some people to come join you on this venture that you're starting and continuing. And thank you for coming on the show today and talking about Pilosa.
Thanks so much, Randall.
Cool. All right. Hey, that was Matt Jaffe and Travis Turner talking to us about Pilosa. What do you think there? I almost called you Aaron. What do you think there, Guillermo? Not enough sleep today. Not enough sleep.
It's fine. It's been one of those days, right? Yeah. So yes, it's a complex concept to grasp, but I can see this actually making a lot of my projects easier to work with. At least post-project, when you need to start, digging into the information, maybe you just pump data into this thing and, pull some data back out. So, I'm going to start playing with this thing. So, I don't know. I don't know what else to say.
I'm just going to start playing with it. Well, that's what I always say about every single project, and I hardly ever get to any of them because then the next week comes along, there's another great thing. But I am going to tell the analytics team here at ZipRecruiter about this thing because they're always looking for new ways to crunch down the data. They're doing a lot of stuff with Elasticsearch right now, and I think this might be a valuable addition to them to get even more data out of DD mining all those wonderful jobs being applied for and employers wanting jobs to be there out there. Anyway, that's enough. Coming up next, we have Magento next week, which is a commerce platform. Think of it as shopping carts on steroids. Immediately following that, Flutter, which is the cross-platform mobile apps written in Dart, my new favorite language. So we got a couple of the lead guys from the Flutter team, which is going to be really fun. Cockpit is after that. That's administering your Linux system via the web. Redis, which is the most popular in-memory key value store. I can't believe we haven't had them on the show before, but apparently we haven't. Brian Bellendorf's going to come talk to us about Hyperledger, which is the blockchain blockchain technology from Linux Foundation. Think like Bitcoin, but also for document verification and public voting, things like that. Jenkins, the leading CI/CD server. It's a fork of Hudson, so we're going to talk about what pitchforks are, where the fork is done under duress. Containership, cross-platform deploy and manage containers. Speaking of containers once again, just added to the schedule, I'm going to be at the allthingsopen.org show, which has actually been running around for 5 years, coming up in October. And I invited the two leads of the show to be on the show to talk about all things open. If you're in the Research Triangle area, or actually anywhere that you can get a plane to there, you might want to check out allthingsopen.org. It's been a successful show, and they'll be on to talk about what that show is all about. LibreOffice after that, they're actually coming back after not being on the show for 5 years here, so lots of things have happened in 5 years. Kazoo also had not been around for a long time. Here. We actually did 2 shows on them, 2600 hertz before they were Kazoo, and then Kazoo. But that was a long time ago, like 3 or 4 years ago. That'll be coming up. And also just added to the schedule, just between last week and this week, the Hiawatha web server, which seems to be it's a lightweight but very secure-minded web server. So done by some guys in Europe. So he's going to be calling in fairly late for him, but fairly early once again for me. So that list can be seen at the homepage for this show, twit.tv/floss. Follow the link there to here's our upcoming guests. There's a link very prominently there. If you have any other suggestions, please have the project leader or team coordinator, whatever, a community coordinator, there it is, email me, merlin@stonehenge.com. My address is on that homepage. I've opened up all of Q3 and Q4 just to make sure that we have slots for all the people that are coming in, because we have so many slots already taken. That's all the way out to mid-July, actually late July. Already booked in, but I want to be able to have places for people to come check in. We do have a live stream. We took a few questions from there at 9:30 a.m. Pacific time, and it has been Tuesdays for many, many years, but we're moving to Wednesdays starting June 28th. The network needed this slot for Tuesday, and I just absolutely agreed. So yeah, just move to Wednesday. You can follow us on Floss Weekly on Google+, and at Floss Weekly on Twitter. You can follow me at Randall L. Schwartz on Google+. That's my primary blogging platform these days. And that also tweets over to @Merlin on Twitter. Again, I'll be at the Pearl Conference coming up in the D.C. area in it's not next week, I think it's 2 weeks from now. I'll be at DragonCon in September, where I'm having a talk on Dart, a 1-hour talk on Dart. And I just found out I'm on 5 other panels. So good old Scott is going to be cruel to me. I'm just going to be all over the place on panels. And then, again, as I mentioned earlier, the allthingsopen.org conference is just now opening up for registration. But I will be there in my capacity as Floss Weekly coordinator to look for even more guests. Guillermo, anything you want to plug?
Well, I'll be in BitCon, I think, near the end of this month. And I guess people can follow me on Twitter, GAMARAL, @GAMARAL. God, I'm tired today.
Look down on the screen. Look down on the screen right below you.
Read that. Read that and Google my name and you'll be fine.
Yeah, yes. Okay, cool. Hey, well, thanks for stepping in, even in your slightly medicated state. I know that you have an issue there. Yeah, I do also want to say, I think today is Simon Phipp's birthday, so we're giving a shout out to Simon. Happy birthday, Simon. So even though he's not here today, he'll probably be back in a couple of weeks when we get a little more further down the schedule. Anyway, that's it for me. We'll see you all again next week on Floss Weekly.